Section 12.1, we are going to explore solids and three-dimensional objects. So we're going to determine if a figure is a polyhedron, and if it is, whether it's a prism or a pyramid. And then we're also going to name prisms and pyramids and identify the faces, edges, and vertices. So what is a polyhedron? Well, a polyhedron is a figure made up of 2D polygons called faces. So you can see here is a face, and this is a face. So these are all faces right there. Edges are where two faces come together. So this is an edge right here. And this is an edge right here. So those are the edges where the faces come together. And then the vertices are where three or more faces come together. So if you look at this vertice right here, you have those two faces and this face in the front all coming together to form a vertice. It's really the corners of the three-dimensional object, and it's kind of where all the edges also come together is another way to look at it. So again, this is just the anatomy, again, of a polyhedron. Again, just another picture. One thing about a polyhedra or polyhedron to think about, like visually, is like a tissue box. That would be a polyhedron. And it turns out that for any polyhedron, the edges, faces, and vertices are related by Euler's formula right down here. Now, it's not something that's super important to like memorize, but it does help you check and count the number of edges, faces, and vertices a little bit more efficiently and easier. So there are two types of polyhedron. There is a prism and a pyramid. Now, the ones on the right in green are not polyhedra. Polyhedra is just the plural of polyhedron. So these are not polyhedrons because of the curves. And because of those curves, there's no polygon faces. Because remember, a face has to be considered a polygon, and polygons are made up of three or more line segments. So that's why these are not polyhedron. So let's talk about the first one. The first one we're going to look at is a prism, created by two congruent bases with a perpendicular height connecting them. So this would be like your perpendicular height. And this would be a base and a base. So the bases here are pentagons, and that's why we call it a pentagonal prism, because it's named by the shape of the base. Now, one other thing to note is that the bases in a prism are parallel to each other. So what you also notice is that all of the other faces are going to be quadrilaterals. And usually they're rectangles, but they could be a parallelogram if it is not a right, if this edge right here is not right and perpendicular. So pyramids, on the other hand, are created with one base, and it comes to a point still named by the shape of the base. So we can see that this base is a triangle, so we call it a triangular pyramid. This base right here is a pentagon, so we would call it a pentagonal pyramid. Now, again, there's only one single base, and so if you notice, one thing to also look for is not only is there only one base, there's not a parallel congruent base with it, but also notice all the other faces in a pyramid are triangles. So all other faces are triangles. So sometimes it's not resting on its base, so you have to be a little bit more of a detective and see if you can figure out what shape it is and whether it's a pyramid or a prism. So let's practice a few of these. See if you can figure out which one of these are polyhedron, and if it is a polyhedron, can you name it by the shape of its base? This is a polyhedron because you can see we have faces that are all polygons. It's named by the shape of the base. And actually we could call this base, the yellow piece, the base, a rectangular prism. We could also use this, the front and back, as a base as well. And it looks like it may be more like a square, but we're going to call it, for what we can tell, a rectangular prism. How do I know it's a prism? Because it has the parallel and congruent bases, and all the rest of the faces are rectangles or quadrilaterals. Okay, the next one over here. This is, yes, is a polyhedron, and it is a prism. And what shape the base is a triangle. So this is a triangular prism. Okay, so this one is not resting on the base. How do you tell? Well, again, look at the base right here. It has a parallel and congruent face that is with it, and all of the other faces are quadrilaterals. So if you look at this right here, that is a quadrilateral. Again, most of the time they look like rectangles. This one over here is no, because of the curves. And this last one is also yes. And here is the base. Okay, if we can, we call the base what it's resting on. But in the one above, it's not resting on the base. It's actually resting on one of its faces. So this, I would say, is also a rectangular prism. Okay. All right. So here's just something kind of interesting, that it turns out that there are regular polyhedra, or there are 5 actually regular polyhedrons. And all the faces are congruent, regular convex polygon. And there are only 5 of them. It's kind of interesting to note that. But it's not something that we're going to be working with much. And then let's finish up here. Let's talk about the cross sections of 3D figures. So the cross section of a 3D figure, okay, it's, imagine cutting the 3D object into 2 pieces, and the shape that's created by the cut is called a cross section. So that's the cross section right in there. Now, you do not have to do the cross section parallel to the base, and depending on how you draw in the cross section determines what the cross section might look like. So if you take this one right here, you can see that cross section is a circle. And this cross section, cutting it the opposite direction, this cross section is a rectangle. And last but not least, I would say this cross section cut sort of at a diagonal is a trapezoid. Now, of course, we don't have the markings to prove these things, but that is the shape. That's what it looks like. So that is the end of section 12.1.